Right, guys. Today, as promised in my last video in this series, we're going to be looking at object-oriented programming today. Now, I'm going to be going through this assuming you've never worked with object-oriented programming before. And so we're going to start with some real basics that some of you might already know. But yes, if you continue down the road, which I mentioned last time, then I'm a big believer in modular programming, the concept of things being kept modular. And I used examples as namespaces in C# being modular, classes themselves are modular, functions are modular, and so forth. Then you'll understand when we get to object-oriented programming now, which incorporates the term a class in most programming languages. That is basically also just a module, as in modular programming, but it's got certain extra features added to it in the way it's made to be modular that something simple like a namespace or a function doesn't have. So if you really think about what is an object, in day-to-day life, what is an object? And I mean, we can look at a couple of examples here. We know these objects very well. And you've got an aeroplane, a little dog. These are just objects. They're not, they're things that can exist on their own. They don't have to. They might be part of something else, like part of the aeroplane, or let's say a part of the aeroplane is, for instance, it's a jet. Okay, part of the robot is its electronic AI brain. They also consist of other parts which within themselves can be considered objects. So objects can make objects, and at the end of the day, if our final object which we wanted was, for instance, a fighter jet or a pretty little, what is this? This is a French bulldog, it looks like to me. If that was your aim at the end of the day, then hey, you've succeeded. You've created an object which is a little bulldog. Through a computer, and you needed your computer to have a monitor, a keyboard, a mouse, and a CPU, hard drive, all that stuff, and you've got all those objects stuck together to create this one big object called your computer. Then you've succeeded, and that is an object in real life. Now the question comes in, all right, if those are objects in real life, what is an object in an programming language? As in, why do they not just say objects? Why is it object-oriented programming? Okay, what does this orientation mean? Okay, so let's see what's the difference. And well, there really isn't a difference. It's the exact same thing. You can have an object, well, it's electronically the same thing, something held in your computer's memory and so forth. But if you wanted, for instance, a aeroplane, a jet plane, you could have one in real life, which is an object in real life. And then you can have the exact same thing, except in digital format in your computer. So in other words, there could be a jet, for instance, a fighter plane in some game you've just created, some version of Battlefield or something like that. The same applies to the jet ski. The jet ski isn't necessarily something tangible you can touch. Like we spoke before, right in the beginning of the series, about like a program, for instance. You can't really touch a program. You can't touch this jet ski object. This object only lives in the computer's memory, and can only be accessible by the computer CPU and so forth. But it can be made to act the exact same way as this object would in real life, in the real jet ski, the real robot, the real shoes, the real cup of tea. So in other words, what object-oriented programming is trying to do is it's trying to create a reflection of reality, as in the reality that we live in. It all consists of objects. and the programming language that's oriented to objects does the same thing. It's leaning towards seeing things as objects and treating things as objects. Now, the important thing about objects is, like I said, they are basically the same as modules, all right, but there's a few differences, and basically it comes down to what they call the 4 principles or the 4 tenets of object-oriented programming. It basically comes down to these 4 things. Okay, if you do these 4 things, then you're fully object-oriented compliant language. All right. So the first thing is you've got to have this idea of an object, all right, which is typically referred to as a class. All right. And it must be able to do certain things, of which the first thing is encapsulation. So in other words, inside that class, like remember I said you got a module like a namespace or whatever, a class is also a module. So inside that module, you can have some data, some variables, all right, sometimes referred to as state, okay, but it's basically just data, all right, a couple of variables, maybe a couple of ints or a few arrays, whatever the case may be. But the thing is they are defined inside this class, okay, inside this object, inside this class, and they are not accessible by anything outside of the class. All right. There are ways of getting to it called properties and so forth. We'll get to that. Okay, and then the next step is abstraction. Okay, now abstraction also ties in with something called the law of Demeter, and what that basically says is if you have got an object, let's say for instance you have a car, all right, some vehicle, and in your vehicle there's an engine, and you want to press the accelerator so that it drives faster. You can't put your foot directly against the engine and turn something on the engine and make it go faster, all right? You actually have to press your foot pedal, all right, inside the car where you're sitting. So you don't have direct access to that engine. The engine is part of the car, that's correct, but the interface that the car presents to you to be able to make it go faster, to press the petrol, in other words, press the pump, the pedal, I mean. So that's called abstraction. So you don't have direct access to the object you're trying to interact with, which is encapsulated inside of this object you're trying to deal with, this class. Another word you can use instead of class is a template. It's a template of an object. All right. So encapsulation is creating variables and so forth inside your class, but not having them accessible from anywhere except from inside the class itself, or through some interface such as properties and so forth, which we'll cover. All right. Then abstraction is you don't have direct access to other objects perhaps inside your class. All right. You have to, on your class, create functions and so forth to do that interaction for you with the object you're trying to access. So in other words, if you want to put your foot to the pedal and push the gasoline down, all right, you can't tell the engine directly to do it. You've got an interface on your class which you tell, okay, press the pedal, and it will go ahead and tell the engine to get more petrol in and go faster. All right, and another very important feature is inheritance. All right, this is you can always think of if you use inheritance, you must think of the terms is a. Okay, some of you might be aware of, you also have a has a, okay, two ways of thinking about something. But when you're doing an inheritance, you think of it is a. So if you have got, for instance, a car, all right, a vehicle of some kind, and it had to be inherited from something else, that other thing would probably be like, let's say your vehicle is some Ferrari, all right, or a Koenigsegg. All right, I love my Koenigsegg's. Let's say it's a Koenigsegg, and the thing about a Koenigsegg is it is actually just a vehicle at the end of the day. So you might have a class defined in your program somewhere which is called vehicle, all right, and then you want a specific vehicle which is a Koenigsegg, And in order to do that is you create another class called Koenigsegg, but it inherits from the vehicle class. So that means you can look at the Koenigsegg as both being a vehicle and in specific a Koenigsegg. All right. One thing about C# is it only allows single inheritance. You can't inherit from more than one object. All right. You can do what they call interfaces. You can have multiple interfaces, which leads to polymorphism, our next point. But inheritance, you basically can only inherit from, well, strictly speaking, two things, but they won't ask you that in an interview ever. The first one is system.object. Everything inherits from that, but for all intents and purposes, don't worry about that. The only thing you can create and inherit from is one other object. So you can create a vehicle and inherit from a vehicle and create a Koenigsegg or a Ford or whatever, or you can create a class called book, and you can inherit from class book and create, for instance, the book Tom Sawyer. So that's inheritance. Inheritance means that a class is another class as well through inheritance. Okay, so if you've got class A and you've got class B, B can be A as well if it inherits from A. So any functions that A had and so forth, B will now have as well. All right. Then when we get to, we'll cover this in detail soon when we start coding. Then we get to polymorphism. And polymorphism is basically a way of looking at your class. You see, I must just say, we normally refer to it as a class, okay? And once we are in runtime, once a program is running, we say an object. All right. A class is basically a template, a blueprint, like a blueprint of a house. Just because a blueprint exists doesn't mean the house exists, but the house is going to look exactly how the blueprint defines it. All right. So you can think of the class. All right. When you create a class in C#, you can think of it as a blueprint. And then when your program is running and at some point that class is actually created and brought into life, all right, and an object is actually made, that's called an instance of a class or just an object. All right, but you can say instance or object. I personally normally say instance, but it's really, people say both. Okay, so and what polymorphism then allows for you to do is you can access your class as if it, you don't need to, let's say for instance, all right, like I was saying, you can only inherit from one other object, but you can implement multiple interfaces. So let's say, for instance, you've got a car, all right, and a car consists of, for instance, an engine, doors, wheels, etc. All these subcomponents that added together make up a class. So what you can do is you can create interfaces. You can say, okay, I want an engine interface that's got a whole lot of functions on it. I want a door interface that's got a whole lot of things like number of doors and so forth. I want a paint interface, which has got maybe a method on there or a property on there saying color. So at the end of the day, you can implement all these interfaces in your class, and therefore it will have things like color, doors, and therefore number of doors, engine, and therefore engine size, and all this kind of stuff. So just remember, in C#, it's single inheritance, but multiple implementation. So now, because you've got all these different interfaces, you can choose to refer to the object as one of those interfaces. So let's say you've got a string of 5 interfaces that you implement from. All right. And let's say it is, again, car. But you only want to have a list, for instance, of all the engines that you currently have in all your cars. You can't really pull out the engines and stick them in some array and access only them. They're part of the car. But because they are created with an interface, all right, called, let's say, car, all right, you typically say iCar, but car, all right, then you can put into your array the object car, but actually point to your Koenigsegg or your Ford or your whatever. because due to the way how interfaces work and how you can access interfaces and pull, which then pulls in the entire object with it, you can then have, you know, strict rules. You can abide by strict rules such as arrays and so forth that only allow a particular type. So it'll say you're not allowed a car that's both a Koenigsegg and a Ford and a Ferrari and a Lamborghini. All right, that's not allowed. Those are different cars. Okay, then you can say, hang on a second, but they all inherit car, or they all have the interface car. And you say, okay, well, add car to the let's say the array, and then suddenly all your cars can be added. All right, but we're going to get into details with that now. So hold on, guys, it's going to be a rough one, but this is sort of getting to this is what you really need to know about C#. After this, you're really going to start needing to know more about the framework and so forth. What are the methods you can call, but the actual programming structures and so forth of C#, object-oriented programming, extremely important to know. All right, so let's say we want to look at this car, for instance, this hot rod, and we would like to represent it in the computer as an object-oriented programming format, as a class, as an object. And well, the first thing you got to do is you got to look at your object, whether in this case it's a physical thing or merely, you know, a conceptual thing in your mind. But yeah, we have an actual photo of an object. So there's a few things that we can immediately notice. All right, it has, for instance, got an engine. It's got wheels. It is painted. The body is made out of a certain material, whether it be iron or, you know, aluminium or whatever the case may be. It's got a number of windows, doors, and a style. In this case, would be a hot rod style. It might be, for instance, a limousine. Might be another style. But let's say we're looking purely at this particular object. In other words, this hot rod car. Okay, so if we are back again at our little Hello World program, let's change it now to be to have an object in it. Now, you could just start typing right here in this file where we are right now, in other words, program.cs. You see in the top left-hand corner here. You can just create a new class in here. You can create a million classes in here. You can create your entire program inside this namespace, for instance, this first namespace, but that is considered poor form. And what's idiomatic in C# is that everything lives in its own file. All right. So if I want to create a new class, I've got to put it in its own file, .cs file. So this code that we're looking at now, for instance, is living in the program.cs file on the right here. So we need to create a new file. Now, you could just right mouse click on your project. All right. And then say add, and then add a new class. All right, you can go to new item, but they know most of the times you create classes, so it's a nice shortcut to go straight to just say class. Right, you can create it right now and it'll create it for you. Yeah, okay, taking a moment. Okay, and it's asking, so what is the name? And well, we want it to be, let's say, hot rod, because we want to class for our hot rod. All right, HOT hot rod, press enter. Now you'll notice that is stuck it, okay, on the same level as program.cs itself. All right, now for a small program like this, there's nothing wrong with that. All right, you'll notice the namespace, the namespace. You'll notice that the namespace, my first application, is the same as the namespace in our first class that we had, program.cs. And remember I said we got class program, and inside that void main, which automatically gets called when our program starts up. So we still got something in the same namespace. It lives in a different file, but we said it's in the same namespace. Now, this is what Visual Studio does for you automatically. If you create a new class, it'll add the namespace for you depending on where you create that class. Now, I just created it in the root of my project, or you know, in the very beginning, top part of my project, where the highest most files lie. and that namespace is called my first application based on what I named my application when I created it. But that's not really what we want to do. We actually want to have Hot Rod not inside there, but what we normally do is we create a new namespace. So you go to add and a new folder, all right, and yeah, you can say, for instance, my classes or whatever the case may be. But when you start getting more into the business environment and for programming for, on bigger projects, it'll be something more to the naming, like the model or business layer or something like that. Now, something in the Microsoft world you come across a lot is they call it model nowadays. So, okay, we'll call it model, all right? So all we did is we created a directory, all right, called model. But now inside there, we want this Hot Rod class to exist. So now I can either recreate it. I can show you again, we can say create a class, create Hot Rod, all right? And it'll create it for me inside the model namespace. And the namespace that it'll be given is my first application dot model. All right. Well, let me show you that. Okay, so let's just go and do that. Let's say add class, and we'll say Hot Rod again. Remember, you're allowed to have the same name for a class as long as it's in a different namespace. Okay, which it is. So we've got two Hot Rods now. Now the one under model, if you look here, you'll see the namespace has changed to my first application dot model. The mere fact that you created this folder, Visual Studio was kind enough and clever enough to know that you probably want that to be its own namespace. So in that sense, there's no clash now between the two Hot Rod classes we've got. Now, there's no reason why these two classes exist. It's actually, they shouldn't. I'm just showing you that due to namespaces, you can have the same class existing in two places. But now, let's say, for instance, we didn't create Hot Rod inside model, all right, using the correct namespace and so forth. We accidentally created Hot Rod like we did just now under the root of the application. Then I created the folder model, okay, which is what our new namespace is going to be. So all I need to do is if I just click on Hot Rod and I drag it up onto model, all right, and let go, all right, it'll move this file across for me. So now it lives inside model, okay. But you'll notice that the namespace is not .model like the file was when we created it inside model just now. You now have to go and add this yourself. All right. This seldomly happens. All right. You normally do it the way I showed you. You create it inside the file, inside the folder, and the namespace will be sorted. But if you ever run into this problem and your namespaces aren't right based on the folder structure, well, just come and change the namespace to whatever the folder structure says it should be. So, okay, we've got a model, okay, or a namespace called model. Well, the full namespace, my first application dot model. And inside that, we've created a class called Hot Rod. All right. Now, if we go and let me just paste those items that we looked at just now. Let me just comment it out so it doesn't cause us any problems. Okay, and all right. So that's commented out code in C# now, so it doesn't give any errors on that. He just assumes I'm just writing something there for myself. It's not part of the program. All right, so like I said, so we've created Hot Rod, all right, which is that Hot Rod we saw on the picture, okay, and we've now created a class, and inside a class, remember one of the tenets of classes is encapsulation. So in other words, its own data it hides from the world outside. All right, data that is not pertinent to the world, it hides and it keeps to himself. Okay, so I can say to you, all right, let's start, for instance, instead of engine, let's start on wheels. So I know that there is going to be a variable called wheels. Now, the outside world must not see it because it has to be encapsulated, all right, to be object-oriented. So the outside world must not know about this variable. So we say in front of it the word private, all right? You'll come across privates and publics and so forth a lot in your coding, right? So we say private, and because it's a variable, we use a camel case. So it's lowercase n for number of wheels, all right? And we just say we start off with naught, but this is where you, oops, sorry, we must say that it's, let's say for instance, a word, a byte, okay, showing our intent that there aren't too many wheels. So I'm starting it off on 0. You don't have to. Remember, I explained previously, if you just say that, you don't initialize it with a value, all right? Because of the type of data type it is, it assumes you mean naught. So you don't have to do that. But just to show another coder and show yourself in the future that you were sure, you did mean to assign this to a naught, just write it out, all right?
Then the other thing that we've got is we've also got let's see, paint windows, number of windows. Let's put that in here. Okay, number of windows. Okay, then we've also got number of doors. Okay, number of doors. And style, I said it's going to be hot rod, so we don't need to worry about that one. Okay, so we've got doors, windows, body material we could look at. Let's put that in. All right, so we've got a encapsulated bit of data.
Now you must decide, okay, what data type do you want to use when you're referring to body material? Do you want it to be a string that contains a word like iron or aluminium, or do you want it to be maybe what is called an enumeration, an enumerator? We're going to look at that as well, but for right now we're going to assume that it is just a piece of string, all right? So we're going to say string, string, all right, and that is for body material. So it's body material equals, and we can also just leave it a naught, okay?
And then we have paint, which could be red, green, blue, whatever the case may be. I know in the picture example I showed you, it fades from one color to another, but let's not get too complex at the moment. Let's just say, just give it a single color piece of text. All right, so we've got wheels, okay, paint, we have everything except engine. Okay, so let's kill all that.
Okay, now up top here I'm going to put in engine, all right? Okay, now we'll call it a string as well. There's many different kinds of engines. This might be, some V8 whatever, or it could be a wonderfully restored quad turbo, multi-supercharged nitrous Mini Cooper engine stuck in there or something. But all right, so like I say, so we're going to make it a string as well for now. And all right, so we've just populated with a value at some point. Oh, I made a mistake down at the bottom here. I created two strings, but I gave them values of 0. Okay, so that was a little mistake there. All right, so in essence, okay, we've actually created an object now, all right, which it's a class called hot rod. Okay, so it's a template of an object which is going to exist at some point in time, which is a hot rod. We're telling it that there's some hidden data inside it, the engine, the number of wheels, windows, doors, body material, and the paint color. Now, in all honesty, a lot of those values actually should not be hidden. All right, you actually want somebody to set what the values are. Like, let's say for instance the number of windows. Some hot rods might have only 3 windows, some might have 8, who knows. So that's a number that can change, and the class itself, there's no code in it that tells it to know that it should be 3 or 8 or whatever. So in other words, it needs to get that information injected from outside. Okay, now there's 2 ways of doing that. That's either by using something called a property, or by injecting it through something called the constructor. Constructor is a very specific function that exists on a class, which we're going to discuss in a moment. So if we just look at the variables, all right. So let's say, for instance, the number of windows, all right. We don't want to hide that anymore, okay, because we actually want somebody to be able to set that. Okay, we want to expose that. All right. So the right thing to do is correct. Okay, so you create the variable, all right, and then you can write a method or a function that says, let's say, so it's a public, means it can be called from outside the class. This is what we want. This is part of the interface of the class. Everything that is public on a class is its interface. So all the other things that you see here, they're all hidden stuff. That's not part of the class's interface. Okay, so as part of the interface, we want a public function, all right, that is going to return, for instance, what did I say, the number of windows. Okay, so we're just going to say, so that is a byte, and it is number of windows. Okay, oops, windows. Sorry, we should say, let's say, for instance, get number of windows. Okay, so all it's going to do, windows, somehow I was just going to say, it seems spelled wrong. All right, so this is just a function, okay, that we're calling, and it's going to return to us the value of, you don't have to put in the word this, but this is also just how things have been going in the C# world lately. When you're referring to one of these, they're also called field variables. Okay, I still do most of the time. My field variables, I'll always start with an underscore. All right, so if any other variable in my entire system has got the same name, I know I'm not referring to the field variable, but rather a variable that's declared inside a function, because you do have access from inside a function to the field variables on the outside. Not good practice, but you do have that ability. All right, so what I want to do is now, so get number of windows. So I want to say return the current value of the number of windows variable. So it's number, this dot number of windows. Okay, and all right, so we've taken some encapsulated data and we've given access to the external world to that data via a function. Okay, now it might not be enough just to get the value of that function, well, because we're only going to get naught and we're only ever going to get naught because nothing ever changes it. So we might also want to have a function that actually sets the value to something. So we don't want to return anything from it. We just want to say set number of windows. All right. Okay. And then as a parameter, remember, parameters are like variables to functions. You can declare a variable inside a function, which is used only inside that function due to scoping. Alternatively, if you want to send it a value from outside of the function, you can send it as a parameter. That's why parameters exist. It makes it modular. So if somebody else wants your function for whatever reason, physically wants your source code, you can just give it to him as is and it'll work for him as long as he's got the right parameter data that he's supplying. He doesn't need to know of anything else that your function does. He just calls it directly, puts the data in it, and it'll get an answer. Okay, so what we want to do is we want to send it a byte, all right, and it's going to be a value called number, all right. Should be number of windows, but let's not get too confused with all the numbers ofs, all right. So then it consists of only one line of code as well, and that is to say that this dot number of windows equals number. Okay. So what we've done now is we've got a class which we've created. Okay, class name is hot rod. All right. We've got some encapsulated data inside it. Okay, that nothing's got access to because they're all private. Then we created two public methods. okay, normal functions, okay, like you've seen me do before. Very normal stuff, this. And all that, the first one is, it says get me the number of windows, so it returns the value of the variable called this dot number of windows. You don't have to put this in, like I was saying, you don't have to. When I used to put in underscores in my fields, I would now, for instance, put an underscore here. So I know that I'm referring to something outside of this function. But the way that is now most typically done nowadays and in other language is just to say this dot. All right, then you know you're dealing with one of your field variables. Okay, so we can retrieve the value, and then down here we can actually set the value. So you can make it, you can call set first, and you say set number of windows to 4, and then you can call get number of windows, and your answer is going to be 4. Okay, now this works, and it's all object oriented, and everything is great and so forth. But C# has made something quite nice for us, and what it comes down to is they've created it's actually, many people do this. They have what they call getters and setters on field variables, and these are often referred to as properties. So, like you can see here, I mentioned, or I named my function get number of windows and set number of windows. So, in a way, that is a getter and a setter function for a variable, for a very specific variable. Okay, but Microsoft has taken it one step further for us, and other languages like C#, there are others. But so what you can do in a lot of languages is, instead of typing out these two methods, all right, you can replace it with, so we're dealing with number of windows, so we'll just copy that piece out, all right, and then delete everything. All right, and then say public, because remember this is a public function, or in this case it's now called a property. Okay, public property, and it's a byte. All right, and we paste the name of what we want it to be, number of windows. You'll notice it's got a capital N, because this is not really a variable, this is a function. All right, and so therefore we use camel case. Okay, so sorry, what is a Pascal case? Okay, so okay, and then you open up your squiggly brackets, and inside there you put in get with the squiggly, and under that a set with a squiggly bracket. All right, and under the get, okay, you say return this dot number of windows. Okay, and under the set you say this dot number of windows equals value. All right, this is the bit you must remember, is value. Okay, so nowhere here do you actually see value as a parameter coming in, but this is how properties work. When you retrieve something, in other words, if you say, if you create a variable called the number of windows, and then you want to make it equal to number of windows, and you'll say byte the number of windows equals hotrod dot number of windows. Okay, and if you want to set it, okay, you'll say hotrod dot number of windows equals 4, and that 4 is what value is. All right, so that's how you can write some of your properties. And what's very nice about this, similar as in a function, you might want to limit, like let's say they set it, okay, and that you don't want to allow them to set it to anything other than maybe only the values of 1, 3, or 8, or any value between 1 and 15. All right, so you can put in some validation here. All right, so you can say if value, all right, the incoming value is greater than or equal to 1, and okay, the incoming value is smaller than or equal to, let's say, 8 windows. Okay, so it's got to have either 1, 2, 3, 4, 5, 6, 7, or 8 windows. So if it is that, all right, then you can set it. set the variable to its new value. Else, okay, because it's failed validation now, it's not between 1 and 8, and you only want it to allow between 1 and 8. Then you can do whatever you want to do. You can say, you can show a message, you can throw something which is called an exception, you can maybe put in a default value, you can say, well, then this dot number of windows equals 1. Okay, so if he makes a mistake, he types anything other than 1 to 8, you're going to change it to 1. But that's what your logic is, whatever your program requires. But so what I'm showing you here is, so we've still got this variable, number of windows, okay? Now we're using something called a property, okay, that's got a get and a set on it, all right, with the concept of a value, all right. But so in a lot of cases, you find you don't need to do any validation, anything, all right. All you want is you've got a variable internally, okay, which you need to allow them to have access to via a public interface of type property, and then they can set it or get the value using this code. But now this is where it gets even nicer. So you don't want to do anything other than just setting or getting the variable. All right. Well, what Microsoft allows you to do through C# is to say, okay, let's get rid of this number of windows variable entirely. And now, we see we get these problems here. All right. That's because number of variables no longer exists. Okay. So don't worry about it. Okay. We get rid of everything. And we say, okay, public byte number windows. Okay. And we do this get and set. All right, and what that has done, okay, when the code gets compiled to Emcel, we'll discuss Emcel at some point. When the code gets compiled, let's say, the compiler knows what you mean by that one line of code. It needs to create what is called a backing variable. Okay, that's these fields up top here, with the one we just deleted. So it will actually go and create one for us because he knows that's what our intent is. He'll do it for us, and he'll create the get and set of that variable for us. The same as the previous code we had. Now it's just done automatically for you. So in other words, you've got these backing variables that are set through a property, but there's no code involved other than one line of code. So you could do the exact same thing with, let's say, for instance, number of doors. All right. You don't want number of doors either. All right. You want it as a property. So just do that. Just go and say number of doors, and then it's a property. And that's part of your public interface. All right. And which has got to do with polymorphism, which we'll also touch on now, just now. All right. So we've got three. Sorry, that I never wrote private in front of my engine here. You should write the word private to show your intent. Okay, so we've still got 1, 2, 3, 4 variables which are hidden. All right, they're encapsulated by the object, and you can't get to them. But then we've got two variables, two field variables, which we do have access to. Okay, and they are properties. Now, the nice thing about a property also is, let's say, for instance, at some point in time, you've written this class, all right, and you've given it to a whole lot of developers. They're all using it, to do whatever, write stuff for factories and whatever, using your code. And then you suddenly realize, oh, heck, no, this number of doors, I forgot to do a check that it's between 1 and 8. Okay. Now, the moment you change, okay, this to look again like our previous code did, where we were working with functions, not with properties, okay, then that is called changing the interface. Okay, that means the interface of your hot rod class has changed, and that's going to cause code on the other developer side to crash and not work and so forth. So by doing this, saying, okay, we're making it a property, all right, but we're not really doing anything. We just say it's a property, and we're getting and setting it like a property. That allows us to come at any point in time, like let's say, for instance, on the set, all right, to change our mind, of what actually happens on the set. All right, and then you can actually put in your code that, for instance, does a check. You know, is it greater than 1 or 2 or 3 or whatever the case may be, and the interface itself will not change. Okay, and that just takes away a lot of headaches from the guys using your code. Okay, and so like I say, you can do, we've got now the concept of your encapsulated code. We're exposing some of that code through properties. That's via that's the beginnings of abstraction. And but let's say, for instance, I did say to you that, for instance, I can't remember body material or paint color, but let's make it the body material. We can make that an enumeration. All right. So what that does is, because it's a string, all right, anyone can type in anything they want in the string. Okay, so you actually want it to be a material. Okay, let's say iron, but they can type the word, you know, Coca-Cola superfragilistics expialidocious inside there, and your program won't know what it means. And you know, and one day if some painter has to paint the car and he sees this on a printout telling him what to do, like, what must I do? So there's a way of forcing people to not add data in there. You know, a validation, like we did just now with a number of doors. There's a way of doing validation, okay, through something called an enum or an enumeration. All right. And that's something you'll also use a lot. This is not specific to object-oriented coding, but you will be using this a hell of a lot, and it makes just for far safer code. So what you can do is, let's say, for instance, this body material. All right, we don't want it to be a string. Okay, it's got to be some enumeration, which is going to lie in a namespace. Let's call it enumerations. All right, doesn't exist yet. So up here by model, we're going to create another folder called enumerations under my first application. All right, and this one is going to be dot, and we're going to say the name of the enumeration is going to be body materials. Body materials. All right, and let's say equal and. Sorry, let's do this the other way around. Body material equals body materials. Okay, now it's going to give us an error. All right, because sorry, we have to tell him. Okay, so we got to give him a data type. All right, body material has got a data type of type body materials. All right, just properly coded there. All right, so it's a data type that exists in the namespace enumerations, which doesn't exist yet. We're going to create it now. All right, it's enum body materials. So body material has to be of type body materials. So like, let's say it's of type integer, then you can't put a floating point number or a string in it. We're now creating our own data type. All right, and it's called body materials. All right, which is an enumeration. So let's take this enumerations. We just copy that into memory there, Control C, and we go into my first application again. You could do this in model, I think. Okay, the better place will be to do it in model. So we right mouse click on model. We're going to create a folder underneath that, and where do we have our, sorry, add, and then a new folder. All right, now it's called enumerations. We just copied it and now we're pasting it from memory. So now we've got a new namespace, my first application .model.enumerations. Now remember, I said everything must exist in their own class. All right, so if I steal this name, body materials, all right, and I click on enumerations, and in here I go and I add a new class. All right, okay, so I add a new class and it's called body materials, and I press enter. All right, it'll take me to that new file that it created. It's got the namespace that is correct, and it's got class body materials. But now this is not a class, this is an enumeration. All right, good friend of yours in programming or in almost any language. So we just change that to say the word enum. Okay, we should say it's a public, because somebody might be using it that's external to our libraries. Okay, so body material. Now, because it's an enum, it allows you to type things slightly different than a class. So you can just start typing, for instance, a name. Let's say, for instance, iron. Okay, comma. Aluminium. I know the Americans are going to moan about how I spell it, but all right, aluminium was my mistake there. And maybe steel might be another option. And oh, just for the hell of it, the whole thing might be built out of wood. Okay, so you've got those options. Okay, those are the only options you have when you're setting a value using the body materials enumeration. You can give them a specific number if you want to. You'll understand why one day in your coding. And you can literally just say, like, for instance, equals 0 and equals 1, 2, 3. But if you don't add the 0, 1, 2, 3, it knows what it is. But you might want that to be, for instance, 100 and this to be equal to 200 for whatever reason. I'm just saying that you can set a numeric value for your enumeration. Okay, so we've got this enumeration called body materials. All right, save that. And if we come back to our hot rod class, all right, okay, he's complaining here about body materials because I gave it the wrong casing. All right, so what he's saying is we've got a data type body materials, okay, and we want to set that data type equal to something. Like if it was, let's say, a byte, you would say equals 1. If it was a string, it'll be equals my surname. So yeah, you do the same thing. So you give it the data type and you say dot, and there's your options that you have: aluminium, iron, steel, or wood. And it can only be one of those. Can't be anything else. Okay, so let's make it, for instance, steel. All right. So now we've said our body material can only be of type body materials and enumeration body materials, and of type steel. This is something you're going to use a lot in your programming, trust me. But now remember, this again is a piece of data, all right, that is actually accessible from outside. So it's encapsulated at the moment and it's private, but this data you do want to access from the outside. Okay, so then you could do the same thing with this shortcut that I showed you here. All right, but there's one little extra step that you can do to that. All right, and this is to create a constructor. Okay, so we can, for instance, say, all right, okay, so it's public, okay, in your body material, okay, and then we say get and set, set. All right, so and let's just pull, wow, what's I've done wrong here now. All right, so let's just pull that out and stick it with the other properties down here. Okay, and so he's happy with that. All right, we've got now this body material variable, all right, that because it's no longer a variable, it's now a property. We have to change the lowercase b to a capital B. Remember your naming conventions of variables, properties, functions, enumerations, etc. But okay, so we've basically created now a property that can accept a value of iron or whatever the case may be. But the thing is, we haven't set it anywhere yet. All right, like we did just now. So one way you can do this is to do it via a const, or let the person set it after they do what they have to create an instance of your hot rod class, create an actual object. Once they've done that, then they can call these properties and set the values to what they want it to be. Alternatively, you can do it through something called a constructor. Now, every class has got a constructor. Even if you don't actually see the word constructor typed, the .NET Core framework, when you build your project, will actually create one for you. Okay, and it's of type public. But you can override that, is what it's called. So you can create your own constructor, okay, and your constructor will take the place of this one that is made for you automatically. All right, so yours will become the actual one. So again, it's part of the public interface. We want the outside world to have access to this. And now the way you define a constructor, it's like a function, okay? But you don't say like void or int or byte what the return type is, all right? You just say nothing, okay? And then you say the name of the class, okay, which is hot rod, all right? Now, if I just put that in, all right, I've just created a constructor. It looks exactly the same as a method, but it has no return type, okay? So you can't say return here at any point, all right? But what you can do with constructor, this constructor gets called the very first time this particular instance of your hot rod class is created. If you create more than one hot rod, they'll all be called, their constructors will be called with the different values you might be sending them. So what I'm saying is, so hot rod now works like a normal function. So we're going to say we want to accept a value for body paint. Okay. Did I delete body paint there? Oh, I did delete it. Darn. Okay, let's just quickly put that back again. So it's that, and we say enumerations dot body material, sorry, not body paint, body material. All right, and then we say body material. Okay, and again with the correct casing, please. All right, so we've recreated that property. Okay, but now remember, there's nothing setting it to any value. All right, but we're going to do it on the constructor. So we're going to send a parameter through the constructor like it was a function, all right? And it's going to be of data type enumerations, enumerations.body materials. We're going to give it a name, body materials. Notice it starts with a lowercase b because it's a parameter, similar to a variable. Okay, and that's it. So we're telling it that there's a constructor called hot rod. It's called hot rod because if it's got the same name as the class, then the compiler knows that this is your constructor. Okay, so it's got to have the same name. So you create hot rod and you pass in your in the parameter list, you're passing the variable called body materials. Okay, or parameter body materials, and then you can say inside here, you just call your property this dot body material equals lowercase, the one that we just passed in. Come on, body. Wow, because I'm typing biddy, not body. Okay, body. There's the one I want. There's the one I want. All right. So, so what we've done is we've actually got. Let's just get back here. Do that. All right. So we've got some encapsulation going here. Okay, with our fields. All right. Nothing can get to them from the outside world. All right. Then we have some allowing access to some of our data, all right, from the outside world through properties. Okay, these three are all properties, and we're allowing not only the setting of that data from the outside world using properties, okay, but we can also do it when you actually create your hot rod. All right, you can send through the body material as a parameter. Now what I mean by that is, let me show you how do you create it. So if we go to our main program, our Hello World program, okay, just after Hello World here, we'll just start typing here. We want to create a new instance of our hot rod, all right? Remember, it's currently just a class, just a template. It doesn't actually exist, okay? It's just a set of rules. Now we're actually going to use one, okay? So now I know that the namespace it's lying in is my first application model enumerations. So now I'm already myself in my first application, the namespace. So I don't have to retype that when I'm trying to access Hot Rod. All right. I just start with model. Okay. So I say, okay, I want to create a new variable. The data type is model.hotrod. Okay. And I'm going to call it my super hot rod. You can call it whatever. Remember, it's a variable name. All right. Equals. Now this is the trick when you're dealing with an object. All right. You say if it's a non-static object. Okay. So what you would normally do. So it's new. All right. You've got to say new. And then you got to tell them what's the data type. All right. So it's model.hotrod. Okay. Now this is where the constructor comes in. Normally you would just say that. Okay. But now I've overridden, I've created my own constructor. Okay. Default constructor. And it requires a body material. So if I hover with my mouse over here, it tells me there's no argument given that corresponds to the requirement, the required formal parameter body materials of the constructor. So what I need to do is I need to now send them a body material type. Now remember, it's in model, okay, and then it's dot enumerations, and then it's dot body materials, and then what do we want to send them? Well, let's send them steel. All right. So what we've now done is in this line of code is we've actually created an instance of a class. So now we have an object. Okay, as an object-oriented programming, we have an object, but we still haven't finished with the 4 tenets of writing an object. So we've done encapsulation, we've done some abstraction, all right, showing how to set your variables and so forth. Okay, but then there are still 2 more. Meaning that we have done encapsulation, we've touched on abstraction, but I feel we can expand on that a little bit more. And then there are the final 2, inheritance, and what we've touched on but still needs to be expanded on is polymorphism. So those will make the 4. But I think, like I say, a little bit of information overload. I think let's leave it at this point, and we carry on in the next video, and we finish object-oriented programming in the next video. So thanks a lot, guys. Thanks for your patience, and well, for keeping up. If you're keeping up so far, you're doing very, very well. Thanks, man. See you. Goodbye.